In question 4 of Module 6 tutorial, we're looking at a sludge balance. So in part A, we're asked to complete the values given in the figure of the tutorial. So this is the setup here. We have primary sludge coming in and firstly getting thickened by a gravity thickener before it enters the sludge digester. We also have secondary sludge from our final clarifier, firstly getting thickened in a belt filter before also entering the sludge digester. So in the sludge digester, a portion of the organic solids is converted into biogas, and the remaining solids enter the centrifuge, where it is further thickened to 21% suspended solids, and then we have our final sludge disposal. So we're asked to fill in the gaps that are currently in this diagram. So initially, we'll start with our primary sludge line. So we have 16,000 kilograms of suspended solids per day from our primary sludge. And this is as it is 1%, suspended solids, we have a volume of 1,600 cubic meters per day. So a suspended solids content of 1% is equivalent to a concentration of 10 grams of suspended solids per litre. And in the gravity thickener, a portion of the water is removed, and therefore we thicken the sludge to 6% suspended solids, which means that our concentration of our output flow of sludge from the gravity thickener is going to be 60 grams of suspended solids per litre. Now this is assuming a density of the sludge of 1,000 kilograms per cubic metre. So then we're going to be looking at our thickened sludge line. So the solids flow is going to be remaining the same, as we've only removed water in our gravity thickener, and we have still 16,000 kilograms of suspended solids per day. And now we need to calculate what the volumetric flow rate is. So we have our thickened primary sludge. We know that it is 6% suspended solids, and that is equivalent to a concentration of 60 kilograms of suspended solids per cubic metre. We know that our solids mass flow is 16,000 kilograms of suspended solids per day. So we can now calculate what the volume of the thickened primary sludge is. It's going to be the solids mass flow divided by the concentration, which is 60 kilograms of suspended solids per cubic metre, which gives us a volumetric sludge flow of 267 cubic metres per day. So we have 267 cubic metres per day. Now if we look at our secondary sludge, we have 11,000 kilograms of suspended solids per day, and we have a volumetric flow of the secondary sludge of 1,833 cubic metres per day. The suspended solids is 0.6% suspended solids, which gives us an equivalent concentration of 6 grams of suspended solids per litre. And we're told that in the belt thickener, the water is removed to increase the sludge concentration to 5% on a mass basis, which then gives us an equivalent concentration of 50 grams of suspended solids per litre. Now if we look at our thickened secondary sludge outlet, we are going to have the same solids mass flow, which is 11,000 kilograms of suspended solids per day, and we need to calculate what the volumetric flow will be. So we're calculating the thickened secondary sludge, and it is 5% suspended solids on a mass basis, which, assuming a density of 1,000 kilograms per cubic meter, is equivalent to a concentration of 50 kilograms of suspended solids per cubic meter. We know that our solids mass flow remains the same as only water is removed in thickening, and so we have 11,000 kilograms of suspended solids per day. From this we can calculate what our volumetric flow rate is of the sludge coming out of the belt thickener, which is going to be our solids flow divided by our concentration, which is 50 kilograms of suspended solids per cubic meter, which gives us a volumetric flow of the secondary sludge of 220 cubic meters per day. So this is 220 cubic meters per day. So now we're going to look at the digester. So the first value we need to fill in for our digester is the inflow values. So we're asked, what is the total number of solids entering the digester? This is going to be the summation of the solids entering in the primary sludge plus the solids entering in the secondary sludge. The thickened primary and the thickened secondary, that is. So that is 16,000 kilograms of suspended solids per day in the thickened primary sludge plus 11,000 kilograms of suspended solids per day in the thickened secondary sludge to get a total of 27,000 kilograms of suspended solids per day entering the digester. So we have 27,000 kilograms of suspended solids per day. Next we need the total volume. Which is the summation of the primary sludge and the secondary sludge, which the thickened primary sludge was 267 cubic meters per day, and the thickened secondary sludge entering the digester was 220 cubic meters per day, which gives us a total volume entering the digester per day of 487 cubic meters per day. So we have 487 cubic meters per day entering. So the next thing that we're asked to fill out in the digester is the detention time. And this can be calculated by the volume of the digester divided by the flow rate. So we know that the volume of the digester is 10,000 cubic meters, and we just calculated the total volumetric flow rate of 487 cubic meters per day, which then gives us a detention time of 20.5 days. So our detention time is 20.5 days. We're then told that we have that 30% of the suspended solids entering are degraded, and we're also told about the biogas production being 1,025 litres per kilogram of the suspended solids that are degraded. So that's the next thing that we're going to calculate. So we'll calculate the amount of solids that are degraded, which is 30% of the total entering. So 0.3 times 27,000 kilograms suspended solids per day, which is equivalent to 8,100 kilograms of suspended solids per day degraded in the digester. From this we can then calculate what the biogas production is. So we have 1,025 litres of biogas produced per kilogram of suspended solids that are degraded in the digester, which equals 1,025 litres times 8,100 kilograms and we're going to divide by 1,000 to get into cubic meters. Which is 8,303 cubic meters of biogas produced per day. So 8,303 cubic meters of biogas produced per day. So now we're going to look at the outflow of the digester, so the digested sludge. So the solids flow out is going to be the remaining suspended solids that were not degraded, and as 30% were degraded, that means 70% are remaining. So it's going to be 0.7 times the total solids inflow, which was 27,000 kilograms of suspended solids per day, which means that 18,900 kilograms of suspended solids exit the digester in the digested sludge. And the total flow, the volumetric flow, will be the same at 487 cubic meters per day. So we have 18,900 kilograms of suspended solids per day exiting the digester, and the volume is going to be 487 cubic meters per day. So the next thing that we have to calculate is what the suspended solids concentration is. So the suspended solids concentration in the outflow of the digester is going to be the total mass of solids, which is 18,900 kilograms of suspended solids per day, divided by the total mass of the digested sludge stream, which is the volume of 487 cubic meters per day, times the density of 1,000 kilograms per cubic meter, which gives us 0.039 or 3.9% suspended solids on a mass basis. So we have 3.9%, which is equivalent to 39 grams of suspended solids per litre. And we're told that the output concentration of the centrifuge is 21% suspended solids. Therefore, we can then calculate the solids flow rate out as well as the volumetric solids flow rate out. The mass flow will be the same, so it is going to be 18,900 kilograms of suspended solids per day, and then we can calculate the volumetric based on the fact that it's 21% suspended solids. So we have our dewatered sludge, for our final sludge disposal. And the centrifuge allows a final concentration of 21% suspended solids on a weight-to-weight basis. So we can calculate the volumetric flow, which is going to be the solids mass flow, which is 18,900 kilograms of suspended solids per day, divided by 210 kilograms of suspended solids per cubic meter, equals a volume of 90 cubic meters of the final sludge, the dewatered sludge, produced per day. So we have 90 cubic meters per day. So we start off with a significant amount of volume, 1600 cubic meters per day of our primary sludge and 1833 cubic meters per day of our secondary sludge. Firstly, we go through thickeners and then a digester and then a centrifuge, and then we have our final sludge disposal of 90 cubic meters per day. So that is part A. In part B, we're looking at determining what the surface area is for this gravity thickener for the primary sludge. So question 4B is to calculate the surface area needed for the primary sludge thickener. So different types of sludge have different solids loading, but the solids loading range for primary sludge is 100 to 150 kilograms of suspended solids per metre squared per day. And these values were provided in the lecture on thickening. So this means that we have a range available for the surface area of the thickening. So the the lower part of the range is going to be firstly our solids mass flow in, which is 16,000 kilograms of suspended solids per day, and we're going to divide that by the solids loading of 150 kilograms of suspended solids per meter squared per day, which gives us 107 meters squared. And for the upper range, we've got again the solids loading of 16,000 kilograms of suspended solids per day, divided by 100 kilograms of suspended solids per meter squared per day, which gives us 160 meters squared. So the area range for the surface area needed for the primary sludge thickener is going to be between 107 and 160 meters squared. Now for part question 4C. We're asked to calculate the minimum volume of a silo required to store the dewatered sludge for a minimum of 4 days. So we calculated that the dewatered sludge volume, so the amount of dewatered sludge produced per day was 90 cubic meters per day, and the required storage time is 4 days. Therefore, the minimum volume of the silo will be 360 meters cubed. Now in part 4D, we're told to improve the suspended solids concentration of the final product, sludge conditioning with polyelectrolytes is introduced. So the PE dosage is 9 kilograms of active PE per tonne, and so we're asked what the daily PE active consumption is. So the polyelectrolyte active consumption. So we're told that 9 kilograms of active PE are added per tonne of dry solids. So from this we can calculate what the daily active PE consumption will be. So it's going to be 9 kilograms of active PE per tonne of dry solids, and we had 18,900 kilograms of suspended solids produced per day, which is then equivalent to 18.9 tonnes per day, which means that this consumption of PE is 170 kilograms of active polyelectrolyte per day. And then in 4E, we're told that with the conditioning, the final suspended solids concentration is increased to 26% suspended solids. It was originally 21% suspended solids. So what is the new storage time in the silo that we calculated in 4C? So we're asked what the new sludge storage time is. So our final sludge production with the polyelectrolyte is 26% suspended solids. So we have our solids loading of 18,900 kilograms of suspended solids per day, and we divide by 0.26 times the density of 1,000 kilograms per cubic meter, which gives us a new volume of 72.6 cubic meters per day. This has been reduced from 90, and therefore we've got a new storage time. So originally we had 4 days storage with our 90 cubic meters produced per day. Now that we've reduced the volume down to 72.6, we've got the volume of 360 cubic meters of the silo, and we're going to divide by 72.6 cubic meters produced per day, which then means that we've extended the storage time to 5 days. So that is the end of question 4. If you have any queries regarding this tutorial, please post them on the discussion board. Thank you for listening.